So in this video, we're going to go over the basic overview of the standard model, and we're going to list all the particles required in the IB syllabus in terms of their basic features or properties. Now, what do I mean by the standard model and more particles? Well, the particles that you should be familiar with are the proton, the neutron, the electron. We've also talked about, during beta emission, the neutrino, the positron, and the antineutrino. These are particles that are released during the emission of a beta particle. But photons have also been discussed when we've looked at absorption and emission spectra. So you already know a fair few, but this is the grand total of particles that you need to start thinking about. You need to think about fermions and bosons and quarks and leptons and baryons. It is quite an overwhelming picture. So let's try and break it down and keep it as simple as possible. To start with, there are two types of particle, fermions and bosons. Fermions are associated with matter, and bosons are particles which carry a force. Let's start with matter particles, because I think that's probably what we're most familiar with, particles that contain mass. So fermions come in these variations. We have two types of fermion. We have quarks and we have leptons. Quarks include the up and down quark, the charm-strange, the top-bottom. Leptons include the electron, electron-neutrino, the muon, muon-neutrino, the tau, and the tau-neutrino. I wish the story ended there, but there are also antimatter equivalent particles. So, in addition to these 12, we have another 12, which are the antimatter equivalent. And that would be the anti-up, the anti-down, the anti-charm, the anti-strange, the anti-top, the anti-bottom. Same with leptons, the anti-electron, the anti-electron neutrino, etc. And I think you get the point. So there are in total 24 new particles to think about. Now, you not only need to know about these particles, you need to know their properties. And the properties we use to discuss the behavior of a quark are the charge, the elementary charge, plus or minus, the baryon number, and the strangeness. Now, we'll come across a baryon in the next video, so don't worry too much, only that you only need to know that all quarks have a baryon number of 1/3. Charge is a little bit trickier. The up, charm, and the top quarks all have a charge of 2/3 E. The down, the strange, and the bottom, they all have a charge of -1/3. So that's fairly easy to remember. Strangeness is an interesting property, and the best way to describe strangeness is that they appear and disappear in a strange way. And by strange, we mean unique fashion, right? So strangeness is a very rare property, and coincidentally, it's aligned with the strange particle, okay? So this one has a strangeness of -1. When we look at the antimatter particles do the same, but the opposite. So the anti-up will have a charge of -2/3 and a baryon number of -1/3. The down quark, the anti-down, would have a charge of +1/3 and their baryon number of -1/3. So they're exactly the same, but the opposite. Now, this information is given to you in the data booklet in this form. So they all, basically, you get the information relevant to the particles themselves. You just need to make sure that you know what these stand for. And you would also then need to put the cap on these And remember what happens with the antimatter equivalents. So for these antimatter particles, this would be minus 2/3 E, and this would be a third here, minus the third, sorry. So this would be minus the third for the antimatter, and this would be minus 2/3. And for your quark, your down, strange, and bottom, you would have a plus a third and a minus a third here. Okay, in terms of strangeness, you get given this information. All quarks have a strangeness number of 0, except the strange quark that has a strangeness number of -1. The anti-strange quark has a strangeness number of +1. So that's everything you need to know about quarks. Let me talk about leptons. Leptons are a different family, and they're a lot smaller. They do not exist in the nucleus, and I'll talk about the strong force a bit later. But quarks exist in the nucleus. Leptons do not. Leptons are fundamental. That means they don't get any smaller. And there are only 6 types of leptons, each with their own antiparticles. Okay, so if I show you the properties of the lepton, what we have is a charge associated with them. So the electron is a -1. An electron neutrino has no charge. A muon has charge of -1. The muon neutrino has no charge. And tau has a charge of -1. There we go. And the tau neutrino has no charge at all. The antimatter equivalents to all of these would have the reverse charge. So the anti-electron, which happens to be called a proton, is +1. The antiparticle, neutrino, would still have a charge of 0. And I think you get the point. They all have lepton numbers. So all leptons have a lepton number of 1, and anti-leptons would have a lepton number of -1. Got that? This is the information that you get on the data booklet. As you can see here, these are the symbols for our 6 leptons. Here is the charge, which happens to be -1. All leptons have a lepton number of 1, and anti-leptons have a lepton number of -1. You get given that information, but also take into consideration that these antimatter particles would have a charge of +1. I like to refer to this diagram because hopefully it will help you to organize all this information. In general, all subatomic particles are split up into 2 types. Fermions, which are matter particles, bosons, which are force particles. Your fermions can be leptons, which are the electrons, etc. Quarks, which are up, down, strange, etc. here. Now we're going to talk about the bosons. The 4 types of boson are as follows: the graviton, W and Z boson, the photon, and the gluon. These are the names of the 4 bosons. The forces that they are associated with are graviton and gravity, the W and Z boson with the weak force, the photon is associated with electromagnetism, electromagnetic spectrum, for example, and here we have the gluon. The gluon is associated with something called the strong force. First thing you need to know is that they are in order. The strongest is the strong force, that's easy to remember. Then it's the photon, the W and Z, and then the graviton. And the forces in order are from strong force, electromagnetism, weak, and gravity. That is the order from strongest to weakest. And that's pretty much it. That is an overview of all the particles you need to know about. And that's also called the Standard Model. Note, I haven't mentioned the Higgs boson. We'll talk about that at the end of the unit.